Now coming to the cerebellar peduncles, these are the topic which is very important from theory point of view. So let us go to the point directly. Come to this cerebellum, which we see this is the midbrain part, this is the pons and this is the medulla. This is altogether called the brainstem. Against the brainstem lies the cerebellum. So because cerebellum developed from the rhombencephalon by rhombic leaf, okay, that is connected with the pons. So coming over here, we see this is the superior cerebellar peduncle which is connected the midbrain with the cerebellum. From the pons, it is the middle cerebellar peduncle connecting the cerebellum with the pons, and this is the inferior cerebellar peduncle which connects the medulla oblongata with the cerebellum. Now again, this is being separated by the floor of the fourth ventricle, which I told in the cranial nerve nuclei. They all will be on this floor of the fourth ventricle. This is the roof of the fourth ventricle, and on the roof we see this is the cerebellum which is present. Now what are the fibers that passes to the inferior cerebellar peduncle, middle cerebellar peduncle and superior cerebellar peduncle? First come to the inferior cerebellar peduncle. Both afferent fibers and efferent fibers travel to the inferior cerebellar peduncles. So what are the afferent fibers? I told that also when the spinal cord is taking the ascending fibers, they always give the information to the cerebellum, okay, because cerebellum is the ultimate decision maker for the motor activity. So this dorsal spinal cerebellar tract which carry the posterior column fibers, the muscle tone, posture, these fibers will be dorsal spinal cerebellar tract corresponding to the nucleus facialis, posterior column fibers, fasciculus gracilis and the fasciculus cuneatus, those fibers will be carried by this. Then there is the anterior external arcuate fibers from the arcuate nucleus of the medulla, then the posterior external arcuate fiber which is from the accessory cuneal nucleus of the medulla. This fiber otherwise called the cuneo-cerebellar tract. So these all together will carry the position cells, muscle cells of the lower limb upper limb, lower limb fibers to the cerebellum by the afferent fibers. From locally from the medulla there are the nucleus, the olivary nucleus. This is a part-olivocerebellar tract. That is from the accessory olivary nucleus. Then there is the olivocerebellar tract, that is the inferior olivary nucleus. Then vestibulocerebellar tract from the vestibular nucleus and reticulocerebellar tract from the reticular nucleus. So these are the main afferent fiber, altogether 7 in number. So these three are very important, and then these three are corresponding to the efferent fiber. Whatever information goes from the olivonucleus, olivocerebellar tract, that will be given by the cerebellum instantaneously by the cerebello-olivary tract. So the information goes from the olivary nucleus, cerebellum decide and then giving the information again to the olivary nucleus. Coming to the cerebello-vestibular nucleus, the vestibular nucleus will give the information to the cerebellum. Cerebellum take the decision and again gives back it to the vestibular nucleus by the cerebello-vestibular tract for the equilibrium to be maintained. And the reticular nucleus will give the alertness that will be given to the cerebellar information. The cerebellum again take the decision and then will return back by the efferent by the cerebello-reticular tract. So corresponding these four is the cerebello-olivary tract, cerebello-vestibular tract and cerebello-reticular tract, which corresponding to these afferent fibers. Intensitaneously the cerebellum will give the information after getting the sensation from this nucleus. So this is the fibers passing through inferior cerebellar peduncle. Coming to the middle cerebellar peduncle, which is a communication with the pons, the only afferent fibers passes through the pons, and it is a pontocerebellar tract. So the pons and the cerebellum, only afferent fibers will go. Now the fibers which is bringing the corticospinal tract fibers, they are carrying the motor fibers from the motor cortex, that is 4 and 6, passing through the midbrain, passing through the pons, goes to the spinal cord, anterior horn cells. So from these it is a connection from the corticospinal tract. These fibers will form the pons to the cerebellum, goes and the communication between the higher center, that is cerebral cortex, lower center, that is the spinal cord, and in between this is called pontocerebellar tract. So whatever motor information is carried by the corticospinal tract, that information is also always given to the cerebellum for the final decision making, for accurate functions of the motor activities, that is done by the cerebellum. Now coming to the superior cerebellar peduncle, it is connecting the midbrain with the cerebellum. It is also having both afferent and efferent fibers. Now afferent and efferent fibers, the lower limb fibers carry the posterior column fibers carried by the ventral spinocerebellar cerebellar tract, which is very much needed for body postural functions of the body with equilibrium. So this is the ventral spinal cerebellar tract. They will not enter through the inferior cerebellar tract. They will enter through the superior cerebellar tract. Another with the from tectum of the midbone is called tectocerebellar tract. These are the afferent fibers enter into cerebellum, and cerebellum will give the only efferent fibers from the superior cerebellar tract, that is dentatorubral tract and dentatothalamic tract. That is from the dentate nucleus, the deeper nucleus, dentate's nucleus, the efferent fibers goes to the red nucleus of the opposite side. So that is called dentatorubral and dentatothalamic tract. That is from the dentate nucleus to the opposite side thalamus. So once it will cross the superior cerebellar peduncle, it will cross with each other. So whatever fibers that is goes from the right side to the left side, and again there is a crossing from the dentate nucleus to the rubral nucleus, so it will come back to its original side. So the contour of cerebellum is always ipsilateral. It will follow the superior cerebellar peduncle goes to the opposite side, and from the dentatorubral tract it will again cross to the same side. So that is the contour of the cerebellum is ipsilateral, while the contour of cerebrum will be contralateral. We will discuss in the next class of cerebrum. So this is the afferent and efferent fibers passing through the cerebellar peduncle of the cerebellum, which is very important from the theory point of view.